In examples 4 and 5 of notes 1.1, we talk about intercepts of a graph. And intercepts are points where a graph crosses the x or y axis. So an x-axis, an x-intercept is a point where the graph crosses the x-axis, and a y-intercept is a point where the graph crosses the y-axis. I'm going to ask you to always express these as ordered pairs, not just as a constant, so that it's clear whether we actually have an x-intercept or a y-intercept. So on our first graph, if we're looking for an x-intercept, we're looking for a point where the graph crosses the x-axis. I highlighted that point in red just now, and that ordered pair is -1, 0. Similarly, if we're looking for the y-intercept, that's where the graph crosses the y-axis. So that would be the ordered pair 0, 2. Please don't write just 2. I want you to write 0, 2 because it's an ordered pair. On the next graph, when we're looking for x-intercepts, we actually have 3 x-intercepts, and we can have an infinite number of x-intercepts on a graph. Anywhere the graph crosses the x-axis will be an x-intercept. So on this graph, we have 3 x-intercepts. They're at -2, 0, 0, 0, and 2, 0. And the y-intercept is where the graph crosses the y-axis. And so that point is at 0, 0. So we notice the x-intercept and the y-intercept can be the same when that point is the origin. So they actually are the same in that graph. Okay, in our next graph, we're going to look for x-intercepts again and y-intercepts. So the x-intercept here is the ordered pair 6, 0. And the y-intercepts, there are 2 in this graph, are the 2 points where the graph crosses the y-axis, and those are 0, 4.73 and 0, 1.27. In our next graph, we have a parabola, and if I'm looking for x-intercepts, there are no points where the graph crosses the x-axis, so there are no x-intercepts. So I'd put none here. So we do not necessarily have to have an x-intercept for a graph. And in terms of y-intercept, we have 1 y-intercept here. That's the order pair 0, -5. The next graph I have is a graph of a circle. So if I'm looking for places where the graph crosses the x-axis, I actually don't have any, right? The graph is not crossing the x-axis, so there are none. And it also does not cross the y-axis, so there are none. So we do not necessarily have to have an x-intercept or a y-intercept. Even without a graph, though, we can find x and y-intercepts algebraically from an equation. So to solve for an x-intercept, let y equal to 0. That's what it means when a graph crosses the x-axis. Y is 0, and solve for x. To find the y-intercept, let x equal to 0 and solve for y. So that will always work regardless of the type of function we're dealing with or the equation we're dealing with. So let's find the x and y intercepts algebraically for the absolute value function that we actually just graphed on the previous page, which is y is equal to 2 times the absolute value of x minus 7. So to find the x-intercept, we let y equal to 0, and then we solve. So we're going to have 0 is equal to 2 times the absolute value of x minus 7. When solving an absolute value equation, you want to first isolate the absolute value. So we get 0 is equal to the absolute value of x minus 7. To remove the absolute value, technically we would write x minus 7 equals plus or minus 0. But plus or minus 0 doesn't really have that much meaning, so we're really just going to do 0. So x minus 7 is equal to 0. Adding 7 to both sides of the equation will tell us that x equals 7. So the x-intercept as an ordered pair is the point 7, 0. Let's now find the y-intercept. So to find an y-intercept for any equation or any graph, you will let x equal to 0. So now we're going to solve when is y equal to 2 times the absolute value of 0 minus 7. So it's 2 times the absolute value of negative 7. So it's 2 times 7, which is 14. So y equals 14. But as an ordered pair, the y-intercept is 0, comma 14.